Hi class, in this video I want to talk about this problem, finding the limits of the function as x approach infinity. So it means the limits of a function at infinity, and we want to find that limit. The first thing you see that if we plug in infinity into x immediately, you will have the form of infinity over infinity. And these, we can take an infinity divided by an infinity because these two might not the same. So we can do this. So what can we do here is that we can simplify this expression. And before we can do that, we have to factor the top and the bottom out completely. So I factor the top, and the bottom is x minus 1 times x plus 1. This is the plus sign. Okay? And at this point, you can simplify x plus 1. Then you will have the limit of x plus 1 over x minus 1 as x approaches infinity. Okay? Again, we still have the form of infinity over infinity if we plug infinity in for x. So we're going to do the next step is that we divide the top and bottom by x. Right? Now we can take the limit. Well, let's do one more step. So it's easier for us to see. If we have 1 plus 1 over x over 1 minus 1 over x. Now we can find the limit. Why is that? I'm going to do it over here. If you look at this expression, on the top, numerator is a constant. Divided by this number is something approach infinity. That means it gets bigger and bigger. So if you think of, if I have $1 and I keep dividing to more and more people, eventually how much money each person have is really close to zero, isn't it? That's why as x go further into infinity, these quantity right here, these two quantity, they both go to zero. Therefore, when we take the limit of this function, this limit become 1 over 1, which is 1. That's how we take the limit of a rational function as x approach infinity.